They say inspiration can come from the most unlikely places. For a scientist at Park, the Xerox-owned research lab in Silicon Valley, it came from a tube of toothpaste. The lab was looking at ways to use Xerox technology, like printing, in other fields.
We started looking at how printing could be used in energy devices. There's a really interesting technology we invented that's called co-extrusion. Co because there's more than one material coming out of a nozzle. And it's quite interesting. Think of it as striped toothpaste. In fact, the inspiration for this, the researcher who discovered it or invented it, he was inspired by striped toothpaste, and he had the idea, well, maybe you could do that at a micro scale and create very, very fine structures.
And that's exactly what they did. By squeezing through a print nozzle, a silver paste surrounded by a sacrificial material that would eventually get burned off, researchers found they were able to get a much finer silver line. The sacrificial material works great at shaping the silver, just like the way striped toothpaste comes out of a tube.
So this is a solar cell. This has been printed with our co-extrusion technology. The goal of that technology, as I said, is to make these lines, called grid lines, as narrow as possible. Because the more blue that you see, the more the sun can actually go down and into the semiconductor and create power. So if you can make the lines narrow and tall, you can actually get more power out of the solar cell.
The researchers say the result, a 5% increase in efficiency.
You can imagine a 100 megawatt production facility. You drop in this kind of printing technology in place of the conventional screen printing, and you're up to 103, 104, 105 megawatts. And the cost for this technology is very similar to what it is for the conventional screen printing.
The system is already in pilot production with an unnamed solar cell maker. And Park hasn't finished there. They're also looking at using the technology in batteries.
Battery is made up of several components. One is the anode, shown here. Another is the separator, which keeps the two electrodes apart from one another. And then what we've shown here is what the cathode would look like if it were made with our co-extrusion technology. Right now the cathode is limited because the lithium ions can't get too deep into the material. So you can't make the electrode too thick, which means you can't have a really great energy density.
Energy density defines the amount of energy that can be stored in a battery, so a higher density is good. It means more power for a given size of battery. The Park researchers have been using their co-extrusion technology to make small channels in the cathode that allow the lithium ions to penetrate deeper.
By doing that, you can now make the electrode thicker, and as you make it thicker, you've basically made the energy density for the whole battery higher. So instead of going 100 miles on an electric vehicle battery, you can go maybe 120 miles. We think that the improvement is on the order of 20%.
The battery is still in the research stage, but the company has already come up with some prototypes like this button cell. They're looking at markets like electric vehicles and power tools for eventual commercialization. At the Palo Alto Research Center in Silicon Valley, this is Martin Williams, IDG News Service.